Good morning, everyone. On behalf of PEC Technology, I'm very pleased to introduce to you our latest innovation, the Energy Management System, or EMS. This solution is designed to revolutionize the way you manage energy, helping you unlock the full performance potential of your assets. As renewable energy and battery storage become increasingly important, the challenge lies in managing these systems efficiently. Our EMS addresses this challenge by serving as the central command hub, seamlessly coordinating your battery energy storage system and solar plants to maximize efficiency and return on investment. More than just a monitoring tool, our EMS functions as an intelligent controller. It collects real-time data from every device and ensures that all assets work in perfect harmony, optimizing performance while reducing complexity for operators. One of the key strengths of our EMS is its unmatched flexibility. Unlike vendor-locked solutions, our system can integrate with any brand of BESS or solar hardware. This gives you the freedom to select the best-in-class components without worrying about compatibility issues. Our EMS also provides powerful analytics and reporting capabilities. Historical performance data and instant reporting allow you to analyze efficiency, diagnose issues, and make informed strategic decisions, ensuring both operational excellence and compliance. Compatibility is another key strength. Our EMS natively supports industrial protocols such as Modbus and MQTT, ensuring smooth connection with third-party systems, monitoring platforms, or cloud-based controllers. The HMI layer supports local plant operation, on-site maintenance, data logging, and interfacing with third-party systems like PV and weather stations. The main part of the slide shows a screenshot of the Energy Management System, EMS, interface, providing a real-time overview. According to the display, a building is importing 68.8 kcal MASNA, while the PV system is idle and the Battery Energy Storage System, BESS, is actively charging at 70% capacity. Further details from the Battery Management System, BMS, show the battery operating between a 20% and 80% limit. The control panel on the right reveals current settings, including a night charge focus, a 20.0 kcal power limit, and enabled toggles for weekend and night charging. The application layers features, which include functional flexibility via parameter adjustment, various PV plus BESS logic, such as energy time shift and peak shaving, BESS protection logic, and local cloud control capabilities. The right side of the slide presents a technical developer interface featuring a window of programming script, a complex graphical block diagram of the control logic, and a real-time monitoring log. The system's equipment layer. The list on the left details this layer's responsibilities, which include the speed and accuracy of its response to commands, self-protection functions for fault conditions, and crucial battery safety features like voltage protection, cell balancing, and thermal runaway prevention. High-level architectural diagram of the Energy Management System. The key takeaway, stated on the slide, is the system's ability to integrate components from different manufacturers, designated here as Brand A, solar inverter, Brand B, power conversion system, and Brand C, battery system. The diagram uses solid lines to represent electrical connections, showing power flowing from the grid provider and the solar battery system to the load consumption. Dashed lines represent the communication network, illustrating how the central energy management system controller communicates with each piece of hardware, the grid meter, and a cloud API, using protocols like Modbus and MQTT to manage the entire integrated system effectively. Now that we've discussed our system's architecture and capabilities, I'd like to introduce the core technology that makes it all possible. This is the EcoStruxure Automation Expert from our partner, Schneider Electric. This platform is the brain of our energy management system. It represents a shift towards software-centric automation, which moves us away from rigid, hardware-dependent systems and gives us the flexibility to integrate diverse components and deploy sophisticated control strategies. As you can see here, it functions as a powerful software-based PLC that adheres to modern IEC standards, handles everything from the control layer to the user interface, and communicates seamlessly over standard protocols. This platform is fundamental to how we deliver an intelligent, adaptable, and future-proof solution. All right, so we've covered the software platform that powers our system. Now let's look at the physical hardware that brings it all to life. This slide details our standard hardware configuration for the control panel, which we call the panel builder. You can see the three primary components on the left: a dedicated power supply, the essential edge controller, which is the Linux-based industrial computer that runs the automation logic, and the HMI touchscreen for local plant operation. BCB to the right, we have a sample bill of quantities. This lists the exact parts from the specific controller model to the permanent software licenses for the EcoStruxure platform and HMI. This demonstrates the complete, tangible package we provide for a reliable and efficient on-site installation. So let's zoom in on the controller we just saw in the configuration panel. This slide gives you a closer look at the essential edge controller, the Schneider Harmony BX1. This is the industrial-grade hardware that serves as the brain of our entire system. Here, we've laid out the key technical specifications to show you what makes this device so capable. You'll notice it has a powerful quad-core ARM processor and 4 GB of RAM, making it more than equipped to handle complex, real-time automation logic. Furthermore, it's built for the industrial environment. It runs on a stable Linux Debian OS. It's DIN Rail compatible for easy panel installation, and it meets critical EMC compatibility standards, ensuring reliable operation. This robust hardware is the foundation that ensures our software performs flawlessly. So, after walking through the individual software and hardware components, this slide brings everything together to show you the complete energy management system, or EMS, in action. On the left is a conceptual dashboard that illustrates the holistic view our system provides. It visualizes the entire energy ecosystem in real time: power from the grid, generation from your solar PV, the status of your battery storage, and your facility's total consumption. More importantly, it translates this operational data into tangible business outcomes, showing clear metrics for cost savings and CO2 reduction. This is all enabled by the core features we've summarized on the right. We leverage a standardized, open platform to seamlessly integrate renewable energy sources. On top of that, we deploy customized applications like peak shaving or energy time shift to actively manage your energy and unlock these financial and sustainability benefits. This is the complete, intelligent solution that all the underlying technology builds towards. Now, beyond the core applications like energy shifting and peak shaving, our energy management system can perform more advanced grid support functions, and this slide shows a prime example. Here, we're looking at the POC voltage control function, where the battery energy storage system acts as a static VAR generator, or SVG. Essentially, we are using the BESS to actively regulate the voltage at your connection point to the utility grid, ensuring high power quality and stability. The graphs on the left show this function in action. The top graph shows voltage fluctuating, while the bottom graph shows the system's response. As the logic on the right explains, whenever the voltage goes too high, our system instantly commands the BESS to absorb reactive power to bring it down. Conversely, when the voltage drops too low, it injects reactive power to boost it back up. This is a critical function for maintaining grid compliance and protecting sensitive equipment, showcasing how our system actively enhances the reliability of your power supply. Finally, let's look at one more advanced application that is crucial for integrating large-scale renewables. This is our PV smoothing function. The challenge with solar power is its intermittency. A passing cloud can cause a sudden sharp drop or spike in power generation, which can be disruptive to the grid. Many utilities have strict ramp rate limits to prevent this. Our PV smoothing function uses the BESS to solve this problem directly. As the graph clearly illustrates, the blue line is the raw, volatile output from the solar panels. The red line shows our BESS actively charging to absorb the sudden peaks and discharging to fill in the troughs. The result is the yellow line, a smooth, stable, and predictable power profile that is fed to the grid, ensuring you always meet the required grid codes. This effectively turns an intermittent renewable asset into a firm and reliable power source. Now we'll look at two of the most powerful and economically valuable applications of our system: energy time shift and capacity firming. These are the core strategies we use to maximize the return on your investment. Energy time shift is about storing energy when it's abundant or cheap, like midday solar, and using it later when it's more expensive. Capacity firming involves using the battery to smooth out the variable output of a renewable source, like solar, to guarantee a stable, reliable level of power. This graph shows a real-world example of both functions working together throughout the day. The green line is the fluctuating power from the solar panels. But the red line, the power actually being delivered, is much more controlled. In the morning, we're discharging the battery to guarantee a firm 1 megawatt of power. Then, as the sun gets stronger, we use the excess solar to charge the battery, shifting that energy for later use. This intelligent orchestration is key to reducing costs and creating a reliable, dispatchable, renewable energy source. To conclude our presentation, I'd like to share the vision that guides our product development. This slide outlines the key goals we are focused on to ensure our energy management system continues to deliver maximum value. Our development targets fall into three main areas. First, for local operation, our goal is to deliver a seamless all-in-one panel that simplifies on-site control and maintenance. Second, for web monitoring, we're moving beyond raw data to provide powerful supervisory tools and summary reports that offer true, actionable insights for planning. Finally, and most importantly, is scalability. By focusing on standard applications and product templates, our goal is to ensure we can rapidly and reliably deploy proven solutions for any customer at any scale. These principles guide our commitment to making our technology powerful, user-friendly, and accessible.